Hello everyone, welcome to this video. This one is paper 1-2 of February-March 2020. Let's move on to question number 1. The first question is, the function f is defined by f of x equal to 1 over 3x plus 2 plus x square for x is less than -1. Determine whether f is an increasing function, a decreasing function, or neither. A function f is said to be an increasing function if f dash of x is greater than 0 for all the value of x, and f dash of x is less than 0, then it is called as a decreasing function. So to find out whether f is an increasing function or a decreasing function, first we need to find out f dash of x, that is nothing but the derivative of f. So here f of x equal to 1 over 3x plus 2 plus x square. Let's find out what is f dash of x. So to find f dash of x, let us write f of x as 3x plus 2 the whole power -1 plus x power 2. So now let us write the derivative. F dash of x equal to, the power is -1, so we'll write -1 multiplied by 3x plus 2 the whole power -2, and the coefficient of x is 3, plus x square can be written as 2x. So let's rearrange this one. You will get -3 divided by 3x plus 2 the whole power 2 plus 2x. So this is our f dash of x. So x is given as less than -1, so that is a negative number. When you substitute the x value in f dash of x, the first term here is 3x plus 2 the whole square. So when you substitute a negative value for x, because you are having the whole square, you are going to get a positive value in the denominator, but in the numerator we are having a negative value. So the first term will be overall negative, and the second term is 2x. So when you substitute a negative value for x, so that term will also be a negative term. So negative term added with another negative term gives a negative value. So that is nothing but f dash of x will be less than 0 for all values of x less than -1. So since f dash of x is less than 0 for all the value of x, this is nothing but a decreasing function. Next, question number 2. The graph of y is equal to f of x is transformed to the graph of y is equal to 1 plus f of 1 over 2 multiplied by x. Describe fully the two single transformations which have been combined to give the resulting transformation. So by looking at the function, we can see there is a stretching and there is one translation. And f of 1 over x is a stretching along the x direction, and 1 plus is a translation along the y direction. So one horizontal, one vertical transformations are there. So we can write in any order. So let us write first the stretching. So stretching by a scale factor. Here the scale factor is 2. So here 1 over 2 is given. So the stretching scale factor is 2, and this is along the x direction. So this is our first transformation. Next is a translation. And the translation vector is 0, 1. Next, question number 3. The diagram shows part of the curve with equation y is equal to x square plus 1. The shaded region enclosed by the curve, the y-axis, and the line y is equal to 5 is rotated through 360 degree about the y-axis. Find the volume obtained. So it's given it is rotated through 360 about the y-axis. So we have to write the equation in terms of x. So the curve equation is y is equal to x square plus 1. From that we'll write what is x square. X square equal to y minus 1. And we need to find the volume. So the limit is given 1 and 5. Okay, so we'll write the formula and directly substitute the values. So the formula to calculate the volume is pi integral volume is equal to pi integral, the limit is 1 to 5. It is rotated through 360 about the y-axis. So the formula here is x square dy, and we know x square here is y minus 1. Let's integrate y minus 1. You will get pi y is y squared divided by 2 minus y. The limit is 1 to 5. Pi square divided by 2 minus 5, and minus of, when you substitute the lower limit 1, you will get 1 square divided by 2, and minus multiplied by minus, it will become plus. This is 1. (25) divided by 2 minus 1 over 2 minus 5 plus 1. You will get pi multiplied by 25 over 2 minus 1 over 2 will be 24 over 2. which is nothing but 12. 12 minus 5 plus 1, you will get 8. So 8 pi is the volume. The next question is, a curve has equation y is equal to x square minus 2x minus 3. A point is moving along the curve in such a way that at P, the y coordinate is increasing at 4 units per second and the x coordinate is increasing at 6 units per second. Find the x coordinate of P. So y is given and a point is moving along the curve in such a way that at P the y coordinate is increasing at 4 units. So that is dy by dt is 4 and x coordinate is increasing at 6 units per second. So dx by dt equal to 6. Okay, so find the x coordinate of P. So to find that, first let's find out what is dy by dx from the given equation. So y is dy by dx equal to 2x minus 2. Okay, and dy by dx can be written as dy by dt multiplied by dt over dx. So we know dy by dt is 4 and dt over dx is nothing but 1 over 6, and we know dy by dx is 2x minus 2. So this is equal to 4 multiplied by 1 over 6 and 2x equal to 4 over 6 plus 2. So x equal to 1 over 2 multiplied by 4 over 6 plus 2. You will get x value as 4 over 3. So this is the x coordinate of P. Next, question number 5. Solve the equation tan theta plus 3 sin theta plus 2 divided by tan theta minus 3 sin theta plus 2 equal to 0 for theta between 0 and 90 degree. So this given equation can be written as tan theta plus 3 sin theta plus 2 is equal to 2 multiplied by tan theta minus 3 sin theta plus 1. Tan theta plus 3 sin theta plus 2 is equal to 2 tan theta minus 6 sin theta plus 2. So we will get tan theta minus 3 sin theta. Okay, when it goes that side, you will get negative 9 equal to 2 will get cancelled, so 0. So this can be written as sin theta divided by cos theta minus 9 sin theta equal to 0. Take out sin theta commonly, you will get sin theta multiplied by 1 over cos theta minus 9. So we can take this commonly, minus 9 cos theta equal to 0. Or we can write this as sin theta multiplied by 1 minus 9 cos theta equal to 0. So sin theta equal to 0 or 1 minus 9 cos theta equal to 0. So sin theta is 0 when theta is 0. So theta is between 0 and 90. So theta will be 0. When sin theta is 0, theta will be 0. So 1 minus cos theta equal to 1. So cos theta equal to 1 over 9. So theta equal to cos inverse of 1 over 9. So which is equal to 83.6 degree. So theta equal to 0 or theta equal to 83.6. Next, question number 6. The coefficient of 1 over x in the expansion of 2x plus a divided by x square, the whole power 5 is 720. Find the possible values of the constant a. This is the binomial expansion question. Let's write the rth term for this binomial expansion, which is 5c r 2x the whole power 5 minus r a divided by x square the whole power r. So this can be written as 5cr 2 power 5 minus r x power 5 minus r a power r, and when the x square comes to the numerator, you'll get x power minus 2 the whole power r. Okay, so we need to find the coefficient of 1 over x. So 1 over x means the power of x when it comes to the numerator is -1. Now equate the power of x from this term as 5 minus r and x power -2 the whole power r is minus 2r equal to -1. This is x power -1. So x power 5 minus 3r equal to x power -1. When the bases are same, you can equate the powers. So 5 minus 3 are equal to -1. So -3 are equal to -6. So r is equal to 2. Okay. So to find the coefficient of 1 over x, we need to substitute the r value as 2 in the general term. So coefficient of 1 over x is 5c 2. 2 power 5 minus 2 is 3. A power 2. And it's given, this expression is equal to 720. Five C2, which is 5 multiplied by 4 divided by 2 is 10. 10 multiplied by 2 cube multiplied by a square equal to 720. So a square equal to 720 divided by 10 multiplied by 2 cube. Which is equal to 9. So a square equal to 9. So a is equal to plus or minus 3. So it's given, find the possible values of the constant a. So the value of a are plus or minus 3. The next part of the question is, hence find the coefficient of 1 over x power 7 in the expansion. So we need to find the coefficient of x power 1 over x power 7, which is nothing but x power -7 so the rth term is x power 5 minus r multiplied by x power minus 2r, which is equal to x power minus 7. So 5 minus 3r equal to -7. So -3r equal to negative. Okay, this will be 12. So r will be 4. So the coefficient of (1 over x power 7) is 5c4. 2 power 5 minus 4, which is 1, and a power 4. 5c4 is 5 multiplied by 2 is 10 multiplied by a value is plus or minus 3, the whole power 4. Because the power is 4, you are going to always get the positive value. So this is equal to 810. So coefficient of 1 over x power 7 is 810. Next, question number 7. The diagram shows a sector AOB, which is part of a circle with center O and radius 6 cm and with angle AOB equal to 0.8 radians. The point C on OB is such that AC is perpendicular to OB. The arc CD is part of a circle with center O, where D lies on OA. So the value of OB is given as 6 centimeter. So that is the radius of the circle. And OC we need to find out, which is the radius of the smaller circle. So we need to find the area of the shaded region. So first, to find the area of the shaded region, let's calculate what is the radius of the inner circle. So we can write OC equal to from the triangle OAC. We know one angle and we know OA value. OA is also 6 centimeter. So we know one side value, one angle. We need to find the another side of a triangle. So we'll use a trigonometric function. So we need to find the adjacent, and we know the hypotenuse as well as the angle, and this is a right angle triangle. So OC is equal to 6 cos 0.8, which is equal to 4.18. We need to find the area of the shaded region, and we know the area of the shaded region is nothing but area of the triangle OCA minus the area of the sector OCD. So first let's find out what is the area of the triangle OCA. We'll use the of AB sin C formula. So of, we know OC and OA. OC is 4.18 and multiplied by 6 multiplied by sine, and the angle is 0.8 radians. And area of the sector OCD of the radius is 4.18, so 4.18 square multiplied by the angle, which is 0.8. So the area of the shaded region is area of the triangle minus area of the sector OCD equal to, so substitute area of the triangle as 1/2 multiplied by 4.18 multiplied by 6 and multiplied by sine 0.8 minus 1/2 multiplied by 4.18 square multiplied by 0.8. On simplification, we get the value as 2.01 centimeter square. This is the area of the shaded region. Next part of the question is, a woman's basic salary for her first year with a particular company is $30,000, and at the end of the year she also gets a bonus of $600. For her first year, express her bonus as a percentage of her basic salary. Her salary is 30,000. Out of 30,600 she gets a bonus. So 600 over 30,000. So to calculate percentage, so multiplied by 100, which is equal to 2%. Next part of the question is, at the end of each complete year, the woman's basic salary will increase by 3% and her bonus will increase by $100. Express the bonus she will be paid at the end of her 24th year as a percentage of the basic salary paid during that year. So the bonus what she gets is so we will use here a arithmetic progression. So to find the nth term, the formula is a plus n minus 1 multiplied by d. So initial bonus she gets as 600 plus at the end of 24th year, so n minus 1 is 23. And every year it gets increased by 100, so D is 100. So this is equal to 2900. So what will be her salary at the 24th year, at the end of 24th year? The woman's basic salary will increase by 3%. So the salary gets increased by 3% every year. So 100 plus 3 divided by 100, the whole power 23. So here I used a compound interest formula to calculate the salary. So this is equal to 59207.60. express the bonus she will be paid at the end of her 24th year as a percentage of basic salary. So the bonus she gets at the end of 24th year is 2900, and to the basic salary, which is 59207.60, and we need to calculate percentage, so this is multiplied by 100, which is equal to 4.9%. Next, question number 9. Express 2x square plus 12x plus 11 in the form 2 multiplied by x plus a the whole square plus b, where a and b are constants. So we need to complete the square here. We will take out the coefficient of x square commonly, so we will get x square 2 multiplied by x square plus 6x plus 11. To make it as a perfect square, we need to add 6 divided by 2, that is 3 square, and subtract 3 square. So x plus 3 the whole square minus 3 square plus 11. So this can be written as 2 multiplied by x plus 3 the whole square minus 2 multiplied by 3 square, which is negative 18, plus 11 equal to 2 multiplied by x plus 3 the whole square minus 7. The next part of the question is, the function f is defined by f of x equal to 2x square plus 12x plus 11 for x less than or equal to negative 4. Find an expression for f inverse of x and state the domain of f inverse. So we can write the given function as y is equal to 2x square plus 12x plus 11, and this can be written as y is equal to 2 multiplied by x plus 3 the whole square minus 7. Now from this, make x as the subject, so you will get y plus 7 equal to, divided by 2 equal to x plus 3 the whole square. So what is x plus 3, which is equal to x plus 3 equal to plus or minus square root of y plus 7 divided by 2. So x equal to minus 3 plus or minus square root of y plus 7 divided by 2. So f inverse of x is negative 3. Here we cannot write it as plus or minus. A function should be 1 to 1, then only f inverse exists. So we should not write plus or minus here. So to check what sign we will get here, it's given x is less than or equal to negative 4. When you substitute x value as negative 4, so here replace y by x, you will get x plus 7 divided by 2 square root of, so minus 3 within square root we will have minus 4 plus 7, which gives 3, Okay, so 3 over 2, so we'll get 1.5, and x is given us, it should be less than or equal to -4. So when you substitute positive here, so -3 plus 1.5, okay, square root of 1.5, you will get a value which is greater than -4. So we have to write a negative sign here so that you will get a negative value for f inverse of x when you substitute the x value as less than or equal to -4. So next part of the question is state the domain of f inverse. So the domain of f inverse is nothing but range of f of x. What is range of f of x? So we know f of x equal to 2 multiplied by x plus 3 the whole square minus 7. So in that you substitute x value as -4. So 2 multiplied by -4 plus 3 the whole square minus 7. So this gives -5. So is the range of f of x. So this will be the domain of f inverse. So domain of f inverse of x is greater than or equal to -5. So this is our inverse and this is our domain. The next part of the question is the function g is defined by g of x equal to 2x minus 3 for x less than or equal to k. For the case where k is less than where k is equal to -1, solve the equation f g of x equal to 193. So g of x is given 2x minus 3. Equation f g of x equal to 193. So let us write what is f g of x. So we have to substitute g of x in the function f. So we know f is 2 multiplied by x plus 3. For x, substitute the value 2x minus 3 plus 3 the whole square minus 7. So it's given this is equal to 193. So 2 multiplied by 2x square minus 7 equal to 193. This can be written as 8x square equal to 200, or x square equal to 25. So x equal to plus or minus 5. And it's given x is less than or equal to k. K is nothing but -1. So x should be less than -1. So we have to take the x value as -5 only. The next part of the question is state the largest value of k possible for the composition fg to be defined. F of x equal to 2x square plus 12x plus 11, x is less than or equal to negative 4, g of x equal to 2x minus 3, and x is less than or equal to k. And we know the composite function exists only when the output of g is within the limit of within the domain of f. So output of g is 2x minus 3, and this should be within the domain of f, which is nothing but less than or equal to negative 4. So 2x is less than or equal to negative 1. So x should be less than or equal to negative 1 over 2. That is k is negative 1 over 2. Next, question number 10. The gradient of a curve at the point x comma y is given by dy by dx equal to negative 2 multiplied by x plus 3 the whole power 1 over 2 minus x. The curve has a stationary point at a comma 14 where a is a positive constant. Find the value of a. So dy by dx is given, and the curve has a stationary point. That means dy by dx is 0 at a comma 14. So substitute a comma 14 in dy by dx. So you will get 2 multiplied by a plus 3 the whole power 1 over 2 minus a is equal to 0. So a plus 3 the whole power 1 over 2 can be written as a divided by 2. A plus 3 is equal to a square divided by 4, or it can be written as 4a plus 12 equal to a square. So a square minus 4a minus 12 equal to 0, or this can be written as a minus 6 multiplied by a plus 2 equal to 0. A can be equal to 6 or a can be equal to negative 2, but it's given a is a positive constant, so we'll take only the positive value, that is a is equal to 6. So you can write here equal to negative 6 or negative 2, positive 6 and negative 2. But this is the final answer. Determine the nature of the stationary point. To determine the nature of the stationary point, we need to find d square y by dx square. Which is equal to 2 multiplied by 1/2 multiplied by x plus 3 the whole power negative 1/3 minus 1. So we'll get this as 1 divided by square root of x plus 3 minus 1. So we got the answer for A as 6. So the stationary point at 6, 14 is 1/6 plus 3 minus 1, which is equal to 1 divided by 3 minus 1. So you'll get negative 2/3, so which is less than 0. So the nature of stationary point is maximum. Find the equation of the curve. So dy by dx is given. From that we need to find what is the y value. So y is equal to 2 multiplied by x plus 3. Power is 3/2 divided by 3/2 minus x square divided by 2 plus c. So to find the value of c, we will substitute the point 6, 14. So y is 14 equal to 2 multiplied by 6 plus 3 the whole power 3/2 divided by 3/2 minus 6 square divided by 2 plus c. 14 minus 2 multiplied by 9 power 3/2 divided by 3/2 minus 36, this is plus 36/2. So c is equal to negative 4. So y is equal to 2 divided by 3/2. You will get 4/3 multiplied by x plus 3 the whole power 3/2 minus x square divided by 2 minus 4. This is the equation of the curve. So the next question is solve the equation 3 tan square x minus 5 tan x minus 2 is equal to 0. So to solve this one, let us use the quadratic formula because this is a quadratic equation in tan x. So tan x equal to 5 plus or minus square root of 25 minus 4 multiplied by 3 multiplied by negative 2 divided by 2 multiplied by 3. So tan x equal to 2 or tan x equal to negative 1 over 3. So x equal to tan inverse of 2 or x equal to tan inverse of negative 1 over 3. So this is 63.4 degree, and here so the x value is negative 18.4. So x value is between 0 and 180. So we'll add 180 here to get the positive value for x. So which is equal to 161.6. So x equal to 63.4 degree and x equal to 161.6. Next part of the question is find the set of values of k for which the equation 3 tan square x minus 5 tan x plus k equal to has no solution. It has no solution. That means b square minus 4ac is less than 0. So here b is negative 5 square minus 4 multiplied by a is 3 and c is k. So 25 minus 12 k is less than 0 or negative 12k is less than negative 25. 12k is greater than 25. So k is greater than 25 over 12. Next part of the question is for the equation 3 tan square x minus 5 tan x plus k equal to 0. State the value of k for which there are 3 solutions in the interval 0 to 180 degree and find these solutions. So quadratic equation is given in tan x and we need to find 3 solutions. Generally the quadratic equation will have 2 solutions and this expression, this equation should be equal to 0 when you substitute the x value, and we know tan x will be 0 when x is 0 and 180. So we need to get a term tan x so that we will get 2 solutions from that. So in order to make tan x equal to 0 from this given equation, we will take the value of k as 0. Okay, the k equal to 0, then we get 3 tan square x minus 5 tan x equal to 0. Take out tan x commonly, you will get 3 tan x minus 5 equal to 0. So tan x equal to 0 or 3 tan x minus 5 equal to 0. So tan x equal to 0, that means x value will be 0 or 180 degree. Okay, and tan x equal to 5/3. So x equal to tan inverse of 5/3, which is equal to 59 degree. So the three solutions are x equal to 0, 59 or 180. Next, question number 12. A diameter of a circle C1 has endpoints at -3, -5 and 7, 3. Find the equation of the circle C1. So two endpoints are given. So from that we can calculate the distance between these 2 points, which is the diameter. So from that we can calculate the center of the circle, as well as we can calculate the radius also. So to find the radius is nothing but diameter divided by 2. So the diameter is the distance between these 2 points. 3 minus of minus is plus 5 square plus 7 minus of minus is plus 3 square equal to 8 square plus 10 square. 164 plus 100 is 164. This is the diameter, or we can write this as 4 multiplied by 41. The whole thing divided by 2. Here also whole thing divided by 2 divided by 2. So this is nothing but square root of 41, which is the radius. And to find the center, which is nothing but the midpoint of these 2 endpoints, (7) plus -3, which is nothing but -3 divided by 2, comma 3 minus 5 divided by 2, which is equal to 7 minus 3 is 4, 4 divided by 2 is 2, comma -2/2, which is -1. So this is the center. So we need to write the equation of the circle, which is x minus 2 the whole square plus y minus of minus, which is plus 1 the whole square, equal to square root of 41 square, which is nothing but 41. The next part of the question is the circle C1 is translated by 8 and 4 to give circle C2 as shown in the diagram. Find an equation of the circle C2. So the center of circle C1 is okay. Let us translate the center of C1 by 8, 4. Which gives the circle C2, center of the circle C2. So x is moved by 8. So 2 plus 8. Y is -1, which is moved by 4. So -1 plus 4. So which is the center of circle 2. Comma 3. So equation of C2 is The next part of the question is the two circles intersect at points R and S. Show that the equation of the line RS is y is equal to -2x plus 13. Okay, it's given the circle C1 and C2 intersects at 2 points R and S. So to find the point of intersection of two circles, we will equate the circles, because at the point R and S the circles are equal. So x minus 2 the whole square plus y plus 1 the whole square equal minus 41 equal to x minus 10 the whole square plus y minus 3 the whole square minus 41. Now let us expand and simplify. X square minus 4x plus 4 plus y square plus 2y plus 1 minus 41 equal to x square minus 20x plus 100 plus y square minus 6y plus 9 minus 41. So the x squared gets cancelled, minus 4x and minus 20x, we will get minus 16x. Y square also gets cancelled, 2y and another side negative 6y. So we will write y term on the left hand side. We will get 8y equal to minus 16x. Now the constants 4 plus 1 minus 41, on the other side 100 plus 9 minus 41. On simplifying that, we will get 100 plus 9 minus 41 plus 41 minus 1 minus 4, which gives 104. So now divide it by 8. So we get y is equal to minus 2x plus 13. So the equation of RS is y is equal to minus 2x plus 13. The D part of the question is, hence show that the x coordinates of R and S satisfy the equation 5x square minus 60x plus 159 equal to 0. Take any one circle equation C1 or C2. In that you substitute the value of y as negative 2x plus 13 to find the x coordinates. So x minus 10 the whole square plus y minus 3 the whole square. For y we will substitute minus 2x plus 13 minus 3 the whole square, which is equal to 41. So expand this one, x square minus 20x plus 100 plus this we get 10 minus 2x, which is nothing but 100 minus 40x plus 4x square minus 41 equal to 0. So x square plus 4x square gives 5x square minus 20x minus 40x gives minus 60x. 100 plus 100 minus 41 is plus 159, which is equal to 0. So the x coordinates of R and S satisfies the equation 5x square minus 60x plus 159.